So Greg, we ask all of our guests if they think there's really any benefit for health professional students to learn about evolutionary biology. Is it just fun, or can they make use of it?
I think it's a lot more than fun. One of the nice things about having an evolutionary perspective is it gives you a relatively simple framework for understanding not just what you see around you, but why it works the way it does. I mean, some things just don't make sense. And if you're sort of banging your head against the wall trying to understand them, that's not where you want to be as a healthcare provider. You want to have insight and a deeper understanding, and not just say, okay, I see a symptom, here's what I'm going to do, but to see behind that symptom.
I mean, for me, I studied biochemistry and memorized all the stuff like you were supposed to, without anybody ever mentioning anything about how it got that way or why it was that way. Once I took an evolutionary view, it became fascinating and sensible.
Yeah. It becomes sensible. It brings order to something that otherwise seems rather random.
Yeah. Other reasons why you think it might be interesting or useful for health professionals to learn more about evolution?
Well, I do think that particularly for the healthcare providers who also have an interest in developing new therapies or new diagnostics, it provides probably a rather fruitful pathway for them to begin framing hypotheses, the most efficient way to conduct their research.
Asking new questions and all the rest. One of the fascinating ones just this year that I've been following closely is recognition that beta amyloid, the stuff that is thought to cause Alzheimer's disease, is a very potent antimicrobial substance.
Really?
You didn't know that?
No.
Oh, it's spectacular work. It was first proposed by Socio back about 7 or 8 years ago, and Moore and the same group at Harvard has now shown that it's a very effective one, and if you inject Salmonella typhi into mouse brains, you get a little cluster of new beta amyloid right around every bacterium.
Wow.
And likewise, they form filaments that entangle fungi. So this is a whole different perspective, and talk about practical.
How?
Many people have tried to develop drugs to interfere with the synthesis of beta amyloid.
It may be a
and they never work. And they never work. The drugs do not work.
Huh.
But now that we have this understanding of what it's there for and why natural selection has shaped a mechanism to synthesize these things, gives me great hope that we're going to make progress.
There's been this idea among people who've studied Alzheimer's that trying to suppress the formation of the beta amyloid plaques may not actually be the right way to go. It itself may be a defense response.
That's right. And
that we might actually be exacerbating the problem if we try and reduce that. So yeah, it's interesting. Yeah.
Whole new arenas. So thanks very much for a wonderful conversation, Greg.
Absolutely.
Really appreciated
it was my pleasure. Yeah.